Good morning, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 13 of graphs 8. And we're still looking at transformation, and this time round we are specifically looking at stretch. And we are told that the two graphs below show a function fx and the function f a half x, note the presence of a half inside the bracket, plotted on the same axis. In each case, the transformation y is equals to fx to y is equals to f a half x is a stretch scale factor 2 parallel to the x-axis. That is said, but I would want us to consult the magic table and explain the same and verify this. The magic table, which I have explained before, is called Mayo, the Mayo table. This is just how I summarize the transformation of curves minus a, 1 over a, and a. And we have Timothy should verify his answer or himself. Of course, M means multiplication, A means addition, I means inside, O means outside, T means translation, S means stretch, V means vertical, and H means horizontal. All these A's are parameters of transformation. We will explain how. And as you can see, and what has been said, the red graph, or the graph drawn using red, is the original graph, y is equals to fx. And I would want us to just highlight one point. For example, this point, x is 1. The moment we have y is equals to fx, transformed to y is equals to f, a half x, you can already see that this is multiplication of the original x by half. And this multiplication is actually inside the bracket. So the moment we want now to consult our magic table, we will talk about multiplication inside. And if you look at it critically, multiplication inside, if we may highlight that, this is multiplication inside. We are saying that this is a horizontal stretch of scale factor 1 over a. Kindly remember, before we go even far, our a here is a half. Our a is a half. And because we are having multiplication inside the bracket, this is multiplication inside, which has been concluded to be horizontal stretch. And for stretch to be realized, we have to multiply. It is multiplication inside, which is horizontal stretch of scale factor what? Scale factor 1 over a, which is 1 over a half. We all know that anytime we divide a number by a fraction, it is like multiplying that number by the reciprocal of the divisor, meaning that it is a horizontal stretch of scale factor 1 over half, which is 1 times 2 over 1. The scale factor is 2. What does that mean? This means all x coordinates are to be multiplied. They are to be multiplied by 2. And that is it. To realize now the graph of y is equals to a half x squared. This x, at this particular point, x is 1. So 1 times 2, we are landing at this particular point, 2. At this particular point, x is 2. You can see, well, y is also 2. 2 times 2, we are actually landing at this particular point, 4. At this particular point, x is 3. This point, x is 3. 3 times 2, we are landing at the point 6. Now, the graph that seems to be black, or the graph I'm now following with this colored pen now, is the graph of y is equals to the function of a half x. You can see how every value of x has been multiplied by 2. If I may want now to take one point, just one conspicuous point in that original graph, transformed to another point using now the transformation that has been highlighted, we can already say, for example, this point, which is 3, 0, the point 3, 0 is transformed to a point 6, 0. Please note that only the coordinates of x are multiplied by 2 and the coordinates of y do not change. But one would argue, even if we would, using this particular point, we would not really know whether y coordinates are changing, because if it was originally 0, then 0 times anything will remain 0. So let's just take this particular point, which is 2, 2, 2, 2. As you can see, it is stretched to this particular point, which is 4, 2, 4, 2. You can again see only the coordinates of x have been multiplied by 2, while the coordinates of y, only the coordinates of x have been multiplied by 2, while the coordinates of y remain the same. So that is it. If we now get to the next graph, we will also say that it is still the graph of the red graph is y is equals to fx, and the black graph is y is equals to f a half x. And again, we are still talking about the same thing, multiplication inside, which is horizontal stretch. Multiplication inside, which is horizontal stretch of scale factor 1 over a half, which is 1, divided by a half, which is 1, times 2, which is 2, scale factor 2. All x values again multiplied by 2. And I just want us to take point, conspicuous point. Here, at this point, x is 90. It is stretched to this point where x is 180. That is it. That is x is 180. At this particular point, the red one, x is 270. 270 times 2 is supposed to be 540, which is the next one. Again, this is 450 for the original one. 450 multiplied by 2 is 900. So you can see the new graph, if we take that point, is transformed or stretched to that point. If we take that point, 270, is transformed to this point, which is 540, and so on and so forth. That point where x is 450, it is transformed to this point where x is 900, and so on and so forth. That is why a point which is known to be originally, let's talk about this, 360 and minus 1, this particular point here. This particular point here is 360 minus, or the original one is 180, 180 minus 1, 180 negative 1. It is transformed to this point, which is 360 negative 1. 360 negative 1. You can already see only the x coordinate is multiplied by 2. the y coordinate does not change. So we confirm through Mayo that this is horizontal stretch of scale factor 1 over a. And that is how easily Mayo can be used to summarize all transformations of graph. Thank you. Follow me and let us meet in the next video.